Okay, so we're on to question 13, which is about a static pulley system. So the acceleration here is 0, this is not moving, and that's going to be absolutely critical in terms of solving the problem. We've got two particles. We know the particles are of equal mass, so I'm going to call this mass m, and there's a downward force mg. And there's going to be a tension in the rope. Now, if I think about what's happening here, I know that mg minus t equals ma, but because a is 0, I know that the tension is equal to the weight. Let me just write that down, just so we're absolutely sure. mg minus t equals ma, but given that a equals 0, mg minus t equals 0, because there's no acceleration, the system's at rest, I can say that t is equal to mg. And after that, I don't need to do anything at all with this particle B, because I know that this is a smooth pulley, therefore the tension up here is the same as the tension over here on particle A. So that is going to equal mg. Now, the second thing I want to do is going to be resolve my forces parallel and perpendicular to the slope. So I've got, this has also got a downward force of mg acting on it. Now, I want to make that perpendicular to the slope, which I'll do in black, and parallel to the slope, which I'm going to do in green. My angle here is going to be theta. Looking perpendicular to the slope, I've got mg cos theta. And parallel to the slope, I'm going to have mg sine theta. Well, let's have a look at what cos theta and sine theta are. Well, I know the sine theta is 0.28. This is 28 over 100, which is 7 over 25. And I'm going to just use a triangle to work out what cos theta will be. So I'm going to do that up here. If I've got theta, I know that sine theta, which is the opposite over the hypotenuse, is going to be 7 over 25. So I can just work this out using Pythagoras as the square root of 25 squared minus 7 squared, which I'm just doing on my calculator here. It's going to give me an answer of 24. So, here, mg cos theta, well, cos theta is 24 over 25, so it's 24 over 25 mg. And the sine theta here is opposite over hypotenuse, which is 7 over 25 mg. Okay, so the other forces which are going to be acting on particle A are going to be my reaction force, which, remember, is going to be perpendicular to the slope, and a frictional force, which we know is preventing this from moving up, which is going to be in green. It's going to be my frictional force, which is mu times r. Okay. So, let's start by resolving perpendicular to the slope. We're going to do it that way. And I can say that R, which is the only force which is acting outwards from the slope, is equal to the only force that's acting inwards to the slope, is equal to 24 over 25 mg. And then I'm going to look at my parallel to the slope, and I know if I'm going up the slope, I can say that mg equals 7 over 25 mg. It's going up the slope, down the slope, plus mu times 24 over 25 mg. Now, this is going to all cancel out. I can cancel mg out from all terms. So that will leave me with 1. And it leaves me with 1 take away 7 over 25 equals mu times 24 over 25. Well, this is 18 over 25 equals mu times 24 over 25. Multiply both sides by 25, bring the 24 down, and it gives you mu equals 18 over 24, which is 3/4.